This is Sven. Sven is a Viking. He and his friends have just sacked the castle, and the king is at their mercy. They tell the king to give them all of his gold, or they'll burn down the castle. However, the king is stubborn and he refuses. But Sven is that rarest of all things, a clever Viking. Sven makes a deal with the stubborn king. He tells them that he will leave the king and castle alone for only 1 gold coin in tribute. The only catch is that next year the Vikings can return for double that amount, with the amount doubling every year. The king thinks this over and realizes that he gets to keep his kingdom and almost all of his gold. He agrees on the deal. The Vikings take their 1 gold coin and leave. The king is happy because he saved his kingdom. However, he may not have made a good deal with the Vikings. The first year, the king pays the Vikings 1 gold coin. The second year, he will pay 2 gold coins. The third, 4 coins, and the fourth, 8 coins, and so on. So far, the king's pretty happy. However, following the same pattern, by the 10th year, the king owes the Vikings 1,024 coins. If the king continues to pay the Vikings this way, by year 15, he will pay 32,768 coins. And by year 20, he will pay a gigantic 1,048,576 coins. The king's tribute to the Vikings is an example of an exponential growth function. An exponential growth function is a common expression in science and business, neither of which the medieval kings or Vikings knew that much about. Exponential growth functions by nature grow very quickly. These functions are modeled as the product of a constant, a, and a growth factor, b, which is raised to the power of x. In the king's problem, the constant a is the amount of money of his first payment with the Vikings. The growth factor is how quickly the function grows. The king's payment doubled each year, so the growth factor was 2. Let's write the function that models the king's tribute. Let x be the time in years, and let f of x be the amount that the king pays. Our function, f of x, is equal to 1 times 2 to the power of x. Let's pick some x values to put in our function. Remember, following the rules of algebra, we calculate the exponent first. We will raise b to the power of x and multiply the result by a. So, if x is 0, then 2 to the power of 0 is 1. Remember, any number to the power of 0, by definition, is 1. Finally, 1 times 1 is 1. This is the value of his first payment. Let's go to the next year. So if x is now 1, 2 to the power of 1 is 2. 2 times 1 is 2. Now's where it gets interesting. If x is 2, then 2 to the power of 2 is 4, and 1 times 4 is 4. Following the pattern, if x is 3, then 2 to the power of 3 is 8, and 1 times 8 is 8. Repeating this process gives us the same output of payments that the king owes the Vikings. So what happens if our growth factor changes? Let's say the king agreed to triple the payment in each year. That makes the growth factor be 3 instead of 2. And the function is now f of x equals 1 times 3 to the x power. This increases the value of f of x much faster. If the king tripled his payment every year, by year 20, he would owe 3,486,784,401 gold coins. And that would probably bankrupt the kingdom. What happens when we change the constant a? In the function, the constant can be thought of as a seed value for our function. It's actually the first value for our function, or in the king's case, 1. What if the king gave the Vikings 5 gold pieces and doubled it every year? As you can see from the chart, each payment would simply increase by a factor of 5. The growth factor on these functions has a much larger impact on the output of the function than the constant, but both are important. Looks like Sven and his pals are going to need a bigger boat.